Hello, seventh graders. Last week, we refreshed our memories on this idea of a ratio. This week, we are going to spend our couple days here before the break and make sure we have a really solid understanding of a very key component of this new standard. By the way, if I haven't mentioned this yet, we have actually moved out of the EE strand. We finished the EE strand. Of course, you guys all know at this point when I say finished, we're never really finished. All that equations and expression stuff will be continued to be used, whatever grammar I'm trying to say. We'll keep using it as we keep moving into this new strand, which is called the RP strand. And you know what that stands for if you go back and look in your booklet. But right now, I want you guys to get out page 35, pens, pencils in hand, and ready to go. All right, starting off right here on the top of the paper, it says, which is a better deal? This is a very real life question that matters a lot if you're ever going to shop for something, okay? So, have you ever noticed how when you go to the grocery store, there's often two different sizes of the exact same product? You might see a 1 pound bag of white rice, and then there's a 2 pound bag of white rice, and then there's a 3 pound bag of white rice. Why are they come in all these different sizes and they have all these different prices? And what are you supposed to do? Well, sometimes it depends on how much you want, but sometimes you can use this idea of which one is a better deal to help you make a decision as to which one you should purchase. Seems like they'd all be priced the same, but in fact, they are not. So we're actually going to do this problem in two different ways to demonstrate something to ourselves. So I'm going to draw that line down there to show I'm going to do it two different ways. You can buy a 14-ounce box of cereal. So you're looking at your favorite cereal, and you see a box that's 14 ounces. That's kind of a small box of cereal. That 14-ounce box costs $2. Or you see right next to it, there's a giant box, 72-ounce family size box, what they call it, of the same cereal, and it costs $9. Well, how are you supposed to choose which one is a better deal? Now, if you remember the saltwater task, we know we're going to have to do some kind of comparison. We can't simply say this one costs more, so it's not as good of a deal. This one's cheaper, so it's a better deal. That would be like saying you used more salt, so yours is saltier. No, 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 we know that's a comparison of salt to water. This has got to be a comparison of money to ounces or ounces to money. And we're going to do that two different ways. We're going to set up a ratio. Let's start with ounces to money. And we're going to put the labels on them. So one of the boxes is 14 ounces for $2. Well, a ratio is a comparison of two numbers by division. Oh my goodness, look, right down here. We're supposed to put that definition. We've said it a couple times now. We may as well write it right here. A comparison of two numbers by division. We will put some examples there in just a moment. But if it's a comparison of two numbers by division, that means I should divide these. And 14 divided by 2 is 7. So that means one of these boxes is 7 ounces for $1. And the other box, we have 72 ounce for $9. Comparison of two numbers by division. Okay, 72 divided by 9 is 8 ounces for $1. Okay, we're going to come back to this idea of which one is a better deal in just a second. Let's look at it another way first, okay? Let's say instead of comparing ounces to dollars, can we switch that around and can we do dollars compared to ounces? So $2 for 14 ounces and $9 for 72 ounces. Now, if I type these values into a calculator, they don't come out as nicely as the other one. And they come out with a totally different answer because they have a totally different meaning. If I do 2 divided by 14, now I'm going to think of this in terms of money because money's on top now. So that I'm going to think of that like 14 cents, okay? So this is 14 cents for 1 ounce. is what you get if you do that division. Really, it's like simplifying and making it out of 1. Okay, 14 cents for 1 ounce. And then if I do the other one, $9 divided by 72, okay, that's going to round to 13 cents. That 5 will bump it up. So this one is 13 cents per ounce for 1 ounce. Okay, so even though this math was easier to do, I'm going to tell you guys right now that sometimes you confuse this a little bit. Sometimes you go, okay, well, this one was less, so this one's a better deal. Oh, shoot, but then you look over here, and this one is less, so this one's a better deal. That can't be a different answer, even though we worked it different ways. So let's make sure we thoroughly understand what these are saying. This one is telling me that I get 7 ounces for every dollar, 7 ounces of cereal for every dollar that I spend. This one is telling me that I get 8 ounces of cereal for every dollar that I spend. That means that the 72 ounce is a better deal because you get more for your money. Okay, that is also verified over here that the 72 ounce is a better deal because it costs less for every ounce. Now, those answers look totally different. 8 ounces for $1 or 13 cents for 1 ounce. But they're actually demonstrating the same relationship. We just need to get some math vocab behind this. Okay, let's put all this together and see, because there's actually so much great math vocabulary in there that I want to make sure we understand. Technically, we set up, we used a ratio, the idea of ratio, but we did a little bit more. So right here, a ratio is a comparison of 2 numbers by division. Well, there's a bunch of ways that we've seen those written. That would be like 14 to 2. Or we also write them 25 to 3, something like that. Or we write them in words, 1 to 3, okay? A ratio though, an official ratio only has the numbers on it. So these are examples of ratios. It's showing me a comparison, but I don't actually have any labels, so I don't know what it is that we're comparing. And that leads us into our second definition right here. A rate. You maybe have heard this word in science or out in the world. What rate are you traveling, or at what rate was the bird flying? Different things like that, okay? The first thing you need to understand is that a rate is still a ratio. It's just building on this definition. So I'm going to start with those words. It is a ratio, which means it's still comparing things. It is a ratio comparing 2 different, and this is key right here, 2 different measurements. Okay, so actually what we wrote up here, when we didn't just say 14 to 2, we said 14 ounces to $2. That was actually a rate. Why? Because we have labels on it. We have measurements. It wasn't just 14 to 2. What's the 14? What's the 2? It was 14 ounces to $2. The measurements here are ounces and dollars. So as soon as you put the labels on it, as soon as you put the measurements on it, you actually have something even more useful than a ratio. You have a rate. Okay? Another example could be that you, I don't know, maybe you earned, let's do a ratio or a rate like this. Maybe you earned $75 in 5 days. Again, that is a rate because it has the measurements on them. It's dollars and days. And the measurements could be anything. It could be pizzas. It could be feet, inches, yards, centimeters, dollars, days, months, years. Okay? Really common things are money and time. Those are often our measurements. But the measurements could be anything. So a ratio is just simply the comparison of the 2 numbers by division. But as soon as you put the measurements on it, dollars, ounces, days, feet, as soon as you put the measurements on it, now you actually have a rate. But a rate is still a ratio. It's just a ratio with measurements. I'll say that again. A rate is still a ratio. It's just a ratio with measurements. Then we get even more specific with something called a unit rate. And in fact, what you did up here on all of these by actually completing the division and doing that mathematical operation and actually completing the division, you turned all of these into what we call unit rates. Now, the fact that the word rate is in it means there's still absolutely measurements. And in fact, the measurements are a very, very important part of writing and using unit rates. You have to be very clear on what those are. But a unit rate, now we're building off this definition. So it starts with, it's still a rate. So we know it has the measurements. We know it's a comparison by division. It's a rate with a denominator of 1. Okay, a rate with a denominator of 1, something out of 1. Look at what all these turned into. Something over 1, something over 1, something over 1, and something over 1. And you'll notice the title of today's notes is unit rates. So much of our focus today is going to be, okay, I have a ratio or I have a rate. Can we turn it into a unit rate and understand what that unit rate is showing us? Here are a couple of examples. Instead of 14 ounces to $2, the 7 ounces to $1 is an example of a unit rate. But also you'll often see it written something like this. Instead of $75 in 5 days, that would be $15 per day. And sometimes, and we're going to learn a lot about how to write it that way, but when they say $15 per day, do you know how many days they're talking about? 1. This is still a unit rate because it is $15 in 1 day. So it's a unit rate, it's a rate with a denominator of 1. Okay, let's make sure we understand the progression of all of these definitions and how we're going to use this today. Down here it says change each rate into a unit rate. So right now they are giving me a rate. So I'm going to actually start by writing out the rate that I have. It says a 5-pound pork roast is on sale for $18.75. Right now, do you see the measurements? I see measurement of pounds and I see measurement of dollars. We're going to practice a lot over the next couple of days how you can write these rates in a couple different ways, just like we did up here. Right now, I'm going to show you the one that makes the most sense to me. It makes the most sense to me if I start with dollars over pounds. Okay. Right now, this is a rate because it is a comparison of two numbers by division with different measurements. It's a ratio comparing different measurements. I've got dollars and I've got pounds. So how do I turn this into a unit rate? Well, I'm going to say one word to you a whole bunch of times through all of this. To turn a rate into a unit rate is always about division. Division, 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 division. Division, division, division. How do we do unit rates? Division. It's all about division. And what do I divide? Well, this bar means divide. So it's telling me right here what to divide. It's the top divided by the bottom. Always. 1875 divided by 5. So what I just found out is I found out that this is $3.75 for 1 pound. I turned that into a unit rate by making it have a denominator out of 1. Okay, and how did I do that? Division. Division. That will always make it out of 1. Another way to say this is that it's $3.75 per pound. And we'll practice writing it all those different ways. All right, let's look at number 2. I'm going to start with a rate. A population of 1,200 people in 6 square miles. So I'm going to start with the measurements they've given me. 1,200 people, 6 square miles. That's an accepted abbreviation. We don't make up our own abbreviations in math, but we can use accepted ones. And I'm going to change this to a unit rate by doing division. 1,200 divided by 6 is 200 people in how many square miles? What's going to be on the bottom? 1. 1 square mile. 200 people per square mile. That is a unit rate. We made it out of 1. And how did we do that? With division. Okay, number 3. You walk 1/4 of a mile in half an hour. Okay, 1/4 of a mile in half an hour. This is called the complex fraction, and these come up a lot with unit rates. We're still doing division though. So really you're just doing 1/4 divided by 1/2, which is really times 2 over 1. You guys remember that mathematics? If you divide a fraction, you really flip it over, multiplying by the multiplicative inverse, which is 2 over 4, which is 1/2 of a mile in how many hours? What's always on the bottom if we change this to a unit rate? 1. 1/2 a mile in 1 hour. If you're like, that really confused me, Miss McGowan, well, you can use the calculator. 1/4 divided by 1/2. You'll still get there. Or you can change them to decimals. 0.25 divided by 0.5. You'll still get there. Okay, so do whatever makes sense to you. But to make it from a rate to a unit rate, all you got to do is division. Now you got to add of 1. Let's try this again. 6 1/4 cups of flour. 6 1/4 cups of flour for 2 1/2 batches of cookies. Will you please notice that I am writing all of these labels because the labels really, really, really matter. Okay, because we're going to actually adjust. This is an excellent way to start off with unit rates, putting it over 1, but we're going to adjust our language a little bit as we move through the next couple of days and get better at our unit rate language. So 6 1/4 cups divided by 2 1/2 batches. I'm going to change these ones to decimals. 6 1/4 is 6.25, and 2 1/2 is 2.5. Oh, 2.5. That's 2 1/2. 2 1/2 cups of flour for every 1 batch of cookies. And why do we put them out of 1? Well, truly, because it makes comparison so much easier. And honestly, it helps us visualize things. If we're like, okay, it's $18.75 for a 5-pound pork. Oh, that's $3.75 per pound. That allows me to compare to the other pork roasts that are around. It also helps me understand, like, if I have some idea, if I'm good at grocery shopping, if I can have some idea of like, well, that's really expensive for pork. It's cheaper at this other place. But it's hard to do those comparisons until you've made it a unit rate. What if they give us a table of values? I have all this table of stuff. Do I really need all of these numbers in order to figure out a unit rate? Truly, no, I really don't. All I need is to pick one pair. So you can pick whatever you want. Maybe I'd pick this one. I'm going to set it up as a rate first. Just a little tip here, money pretty much always goes on top. Okay, it usually makes sense to say dollars per something. So that's why I'm putting the price on the bottom. It's $7.50 for a 10-pound bag of onions. That is a rate. Let's turn it into a unit rate. I'm even going to change colors on these ones to show that I'm getting a unit rate. All I'm doing is dividing it. 7.5 divided by 10 is 75 cents over what? Over 1. Unit rate always turns everything into a denominator of 1. So this, all of this is showing me is that onions are 75 cents per pound. That's what that's showing me. Okay, let's try this one, this table here, number 6. Again, pick any pair you want to. It doesn't matter. We can pick the first one. Do you think it makes more sense to figure out teachers per student or students per teacher? Based on the numbers given to me here, I think that students per teacher is going to work out a little more nicely. But as you'll see as we work tomorrow, you really can calculate it both ways. It's just usually one or the other way makes more sense. So do the division. 100 divided by 4 is 25. This means it is 25 students for 1 teacher. This is a rate because it is a ratio with measurements, and this is a unit rate because it is a rate with a denominator of 1. We're going to be practicing a ton of unit rates over the next little while. And here's really where they become useful. Look at number 7. Both Nigel and Peter are working part-time jobs during the summer. Nigel worked 22 hours one week and earned $159.50 before taxes. During the same week, Peter worked 15 hours and earned $101.25 before taxes. Who makes better money? This comparison is going to be a lot easier if I turn these rates into unit rates. So let's start with Nigel. And again, this is why you usually put money on top, because what sounds more reasonable to you, hours per dollar or dollars per hour? dollars per hour makes more sense to me. So if the wording starts with dollars per hour, that means dollars needs to come first. Dollars need to go on the top. So Nigel was $159.50 for 22 hours. Okay, so right now, well, I need a label on that so that it's a rate. I need all those labels so that it's a rate. So now I'm going to change it to a unit rate by simply going 159.50 divided by 22. And this tells me that Nigel earned $7.25 per hour. That means it's over 1 hour per hour. He earned $7.25 per hour. Okay. Peter worked 15 hours and earned $101.25. So we're going to do dollars over 15 hours. We all know now, hopefully, that unit rates are simply found by doing division. 101.25 divided by 15. $6.75 per hour. How many hours? 1 hour. So if Nigel earns $7.25 per hour and Peter earns $6.75 per hour, who makes better money? Nigel. He earns more per hour, so he is making better money. These comparisons are so much easier if you do a unit rate. And that's what you're going to practice. You're actually going to practice which one is a better deal, like your grocery shopping. That's what your Canvas quiz is all about. But one more example first, number 8. The price of several other pork roasts are shown in the table below. Oh, pork roast, that's all the way back to this problem up here where we found out this pork roast was $3.75 per pound. All right. Mark in the table whether each package costs more than, less than, or the same as the 5-pound pork from number 1. Well, the first thing we have to do is we have to change these rates into unit rates by doing division. Okay, and I didn't leave a spot in the table for that, so I'm going to come over here and show it over here. So if this one is $13.99 for 3 pounds, I'm going to do dollars divided by pounds because I want to figure out cost per pound. I can't do this comparison when they're all out of different things. That one was out of 5 pounds. This one's out of 3 pounds, 2 3/4 pounds, 6 4. They're all out of different things. So if I want to make a comparison, that is what I need a unit rate for. All right, so this was $4.66. So this, I'm going to write this, $4.66 for 1. Oh, there's that weird abbreviation, LB. That's $4.66 per pound, okay? And actually, we don't even have to write, because we always know it's out of 1. You'll see as we get better at this, we don't even have to write that. We can just write per pound. The slash means per. And we'll practice that a lot more over the next couple of days. Now this 8.8 divided by, if I know some of these quick conversions in my head, it can make my calculator work a lot simpler. You can type in the fraction, but 2 3/4 is really 2.75. Remember how we memorized a bunch of those conversions? And you probably still have a conversion chart in the front of your notebook. By all means, use it. It will help with a lot of this stuff. 8.8 divided by 2.75, 3.2. Okay, money-wise, that's $3.20 per pound. Okay, let's keep going. 22.47 divided by 6.4 is about $3.51 per pound. $3.51 per pound. And then here, 5.62, again, conversions, 1.5 is really 1.5. And that's about $3.75 per pound. So what we were supposed to do on these then is mark if they are more expensive, less expensive, or the same. So I'm going to write up here that problem number 1 was $3.75 per pound. That's what we found out for that 5-pound pork roast up there. So this one is more. This one is less. This one is less. And this one is the same. Those comparisons brought to you by unit rates. They're made possible by unit rates. So for your Canvas quiz today, you're going to do a little grocery shopping and you're going to find out for me which one is the better deal. Keep these notes out so you can look at things as you work. If you have any questions at all, please let me know.